Before I explain this example, let me consider the Venn diagram for 3 events or 3 sets. This is the Venn diagram for 3 events. The sample space S is represented by the rectangle. The sets or events A, B and C are represented by the 3 circles A, B and C. This is the common region. So we can say this is the region A intersection B intersection C. Then this one, that is the only A and B. Similarly, what is this region? That is only A and C. The next region is only B and C. Now consider the circle A. So what is the last region of the circle A? That is only A. Similarly, we can understand only B and only C. Now how about the out of the circles? Region out of the circle. That is not A or B or C. Then how about this region? That is A and B. The region A and B includes 2 regions. Only A and B and A and B and C regions. Right. Now let me explain the example. First, pause the video and read the problem. Right. First, understand how many events. There are 3 events. What are those? Gymnastics, baseball and soccer. I use GM, BS, SC respectively. Now let me write down this information using notations. 28% watch gymnastics, so probability of GM equal 0.28. Similarly, probability of baseball BS equal 0.29, probability of SC equal 0.19. 14% watch gymnastics and baseball. What is the N mean? N is the intersection, right? That is probability GM and BS equal 0.14. 12% watch baseball and soccer. That is the baseball and soccer. And the last one, gymnastics and soccer, probability is 0.1. Then 8% watch all 3 sports. That is the intersection of all 3 sports, GM and BS and SC. I am going to explain this example using 2 methods. One is using the Venn diagram. Second one is using formulas. Right. First, using Venn diagram. Since there are 3 events, this is the Venn diagram for this example. First, we consider the common region. What is the probability of the common region? That is the probability of GM and BS and SC, which is 0.08. Then I consider this. That is the probability of GM and BS. It is 0.14. But you see 0.08 is already in this region. Now we need to find the only GM and BS. How do we find the probability of only GM and BS? 0.14 minus 0.08, it is 0.06. Similarly, you can find probability of only GM and SC using this. Probability of GM and SC equal 0.10. So 0.10 minus 0.08, which is 0.02. Similarly, using this 0.12 minus 0.08, it is 0.04. Right. Now let me consider the probability of GM. In this circle, the probability must be 0.28. But we do already have some probabilities, 0.06, 0.08, 0.02. Add them together, that is 0.16. Then how do we find the only GM? 0.28 minus 0.16, which is 0.12. Similarly, you can find only BS using this 0.29 minus the probabilities we already have in BS, then 0.11. And the only SC using this, that is 0.05. Now we need to find the probability of the region outside of the circles. How do we find the probability of the outside of the circles? We know probability of the sample space is 1. So 1 minus whatever we have in the circles. So probabilities of in the circles are 0.48. So 1 minus 0.48 is 0.52. Now read the question. Calculate the percentage of the group that watch none of the three sports. So none of the three sports mean what? That is the region or probability outside of the circles. So what is the probability outside of the circles? It is 0.52. Therefore, answer is 52%. Now, we go to the method 2 using formulas. So first, write down the question using notation, asking none of the three spots. Probability of none of the three spot is probability of B union G union S complement, right? So can you remember the complement rule? Yes, we can apply this to our example, that is 1 minus probability of B union G union S. Now we know the addition rule for 3 events. What is the addition rule for 3 events? Is this. Then we have all probabilities, just plug the numbers and get the probability of B union G union S. But we need the complement of that. So using this, we can write 1 minus 0.48, which is 0.52. Therefore, the answer is here also 52%.